Rewrite the polar equation r as a Cartesian equation. Well, to do that, let's remember x is r cosine theta, y is r sine theta. So that means that cosine theta, if you're looking at this one, you can divide both sides by r. Cosine theta is x over r, and sine theta, in case we need it, is equal to y over r. Okay, so looking at our formula or our equation, we have r is equal to 3 over 1 minus 2 times something. Well, cosine of theta is x over r. So I have r is equal to 3 over 1 minus 2x over r. What I could do is multiply both sides by that denominator. So these go away, and I can distribute this one. So I have r minus 2x is equal to 3. Let's go ahead and solve this for r. So I'm going to add 2x to both sides. r is equal to 2x plus 3. Okay, so let's remember one other thing that we know. First of all, we can't have an r because we need a Cartesian equation. So we need all x's and y's. Preferably, you want it to be solved for y in the whole process. We also know r squared is x squared plus y squared. So can't I square both sides so that I have an r squared? Let's see what that does for us. So r squared is x squared plus y squared. I can subtract x squared from both sides. Now, if you wanted to at this point, you could multiply all this out and combine your like terms. For now, it's okay to leave it in this form. Take the square root of both sides. Don't forget plus or minus. So we have y is equal to plus or minus the square root of 2x plus 3 all squared minus x squared. We have written it in Cartesian form. Now, I will let you put these into your calculator to check them, but when you do, it will come out something like this. When you graph the 3 over 1 minus 2 cosine theta on the polar grid, you get this picture. And whenever you graph this equation, you end up with this picture. By the way, you can see how they left the equation here. It's actually better in that form, but to put it in your calculator, it needs to be in this form.